project. I just want to thank my advisors for being there and giving me good advice in terms of the best way to continue on with my code. There's Tim Onschik, and he is in a Skype call right now. He's a systems architect at TrustWave, and he was involved with Spider Labs, which is essentially the data security part of TrustWave, and that's why I sort of picked him as an advisor, because he would have a little bit of experience with that. And I also have Dan Baresti, who's in the audience today, and he's a senior software engineer at TrustWave, and I wanted to include him in my project because he would be able to give me good insights into my code, as well as just a direction for where I should go. And then my support advisors, because everyone needs a good support. My dad, who's also a senior software engineer, so he could have given me a few pointers along the way, as well as my mom, who's a senior test engineer. And then, obviously, Mr. Sarnowski, who is my great AP computer science teacher who taught me a lot about code and just helped me get to where I am today. As well as Jason Matney, who is a fellow AP advanced topics student, and he's doing the video game, if you saw that. As well as Robert Combs, who's obviously my boss and owner. Now, let's go into my timeline, and then I'll build off of that. So what I wanted to do in the month of October is implement those obfuscation algorithms that I was talking about in terms of scrambling data however the user wants. As well as figuring out how can I combine these two distinctly different programming languages of C++ and C# at the time. And then during fall break, I wanted to create my initial UI. And one of the main inspirations that I came to was using the UI of TrueCrypt. And TrueCrypt is essentially an application which allows you to encrypt your data, but it's slightly different from mine because it really only focuses on just encrypting data in one way. Not necessarily obfuscation, not necessarily steganography, which I would add into my application. So in terms of interoperability, and interoperability is just the technical term for combining two programming languages. So in order to combine C++ and C#, what I would have to create is something called a dynamic link library file, or a DLL file. And essentially what I would do with my code is I would put this into my C# code, where essentially this is my C# code, where essentially I'm importing a DLL, and then this is the definition that I would put in C++. And essentially what this will allow me to do is take one method from one programming language and call it in another. And then this labeled in red is essentially things which I would research later due to either changes in programming languages or just stuff that I have forgotten at that time. So then I would look at Java and C# interoperability and how I can combine those two programming languages. And at first, I would use a utility called IKVM, which would essentially take the compiled output of Java and convert it to an executable, which I could then run in C# and get the output from. And then I would also have something, later I would use just a simple jar file, because I figured, why do I need to convert Java compiled code to an executable when I could just simply run something called a jar file? In terms of my UI design, this is something that I was working on during fall break. So this is the main UI window, which you see when you open up. And this is a test of a good portion of the algorithms that I've been working on. And then there's some beautiful text right there, which says just about the same thing. So why don't we look at when we press the set cipher button. So when we press the set cipher button, what I can do is I can define a key which the user wants to encrypt their data with. And essentially with my key, what I essentially have is an operation or a general module to my program because I built it modularly, and then a operation that I want to run in that module. So essentially what I have is an obfuscation module, and I could do something as simple as reverse the data all the way to mangle the data until it's completely ununderstandable. And then later I would implement this hash generator around the month of January in order to make it so that you could create little secure passwords for yourself. And that's really what hashes are. So whenever you have an algorithm which could accept a password, then you could essentially generate a bunch of random characters for your password and make it secure in that way. And then I would also have input settings. So not only can you just simply encrypt text, but you can also encrypt entire files with the program. And then the encrypt button, I mean, pretty self-explanatory. You can pretty much just press that button to encrypt with the key that you already have. And then the toggle button, which essentially just toggles that encrypt to a decrypt button so you can decrypt your data for later. Now let's talk about obfuscation in a little bit more detail. So I've been talking about it as a method of just mangling data. And this example is looking at the transposition cipher. So essentially what we take is this X marks the spot, and we essentially could load that in horizontally. And then the idea is to then read it in a different way. So essentially when I have a matrix, or a two-dimensional array, or just a spatial arrangement like that, if I read it in a different way, I'll get something which is spatially different. And the only way that I could crack this is either by computer algorithms or by simply figuring out the dimensions of that array. And the reason why I implemented this is not because it was secure, but because it was a historic algorithm that was used for at least thousands of years. And combining this with modern algorithms will only make what you're encrypting more secure. And then read differently. And then that's my new way of saying hello world. That's quite a beautiful way to say that. And that I love Unicode with its random characters. But it's really, this concept of encrypting hello world in this way is really hinging on the concept of something called bitwise XOR. And essentially what that means is each character can be represented as a numeric number. So say an H is like a 52 or something, or let's just say it's a 53. And then a 38 might be something like in lowercase a or something like that. And essentially what I could do is I could take the binary representation of that number, or the ones and zeros which make up that number, and the ones and zeros which make up the other letter in that number. And then what I could do is, if both of the ones or zeros are the same, then I essentially just write a 0 there. Otherwise, if there's at least 1, 1, then I could put it as a 1. And effectively what I could do is I could take an H and a J and then effectively squash them together to make maybe a Q or something like that, or some weird character, such as in the case of that. In terms of my timeline for November, really the idea hinged off of this idea of steganography. And this is my original understanding of steganography. It's a little bit more complex than this. You can't just simply take a text box, drag it over an image, and then there you go, hidden data. But I also wanted to finish my obfuscation methods, which I've been working on during the month of October. And then another part of research and implementation of image steganography is understanding the libraries which I have at my disposal in C++ to manipulate images. And steganography, once again, is just taking data and storing it in a place where you least expect it. And an image is a pretty good place for that, and that's where I started. So at first, I was looking at least significant bit steganography. I'll talk a little bit more about that in the next slide, as well as JPEG cosine curve steganography. And JPEG cosine curve steganography is something that I found while I was browsing some website. And I was like, oh, that's cool, I'm going to do that. And I think I could do that in about a week. Ah, no, that's a master's thesis topic. I messed up. And I never really got to the implementation of image steganography because of this big issue, which is file encoding and interoperability errors. And effectively what happened was computers essentially represent characters in different ways. So essentially you could have something like UTF-8, where essentially it's expecting a number between 0 and 128. Or you could also have something where it's like UTF-16, where it's 0 to 6,500, whatever. And essentially with C++, the only thing which it supported was UTF-8 by default. So what I had to do is go into my code and completely rewrite it so that it could be able to support more characters. Because effectively what I was doing was, if I wanted to encode something like an emoji, it would turn into a square. And with letters, I mean, 0 to 128 is enough to represent letters, symbols, and things which we commonly use in the English language. But if I wanted to move to another language, that would be a problem. So that's why I use the month of November to try and fix those issues in order to make it more universal. In terms of image or LSD steganography, let's talk about that. It's obviously hiding data in plain sight, but how exactly? So why don't we take some binary data? Let's say that's the word hello, 1011. And effectively what we could do is we could take each of the pixels, and each of those sets of 5 are going to be pixels. Essentially what each of those binary representations are numbers. And those numbers, effectively what you could do is you could take the least significant bit, or those bits, and effectively what those are effectively just numbers. And imagine a really big number like 60,000. If you modify the ones place, it's not going to make a big difference. And effectively what I could do is I could take each of those ones and zeros and effectively plot them in there with only a difference of plus or minus 1. And effectively what you get is a color difference of that 1 pixel. In terms of my timeline in December, there isn't really much fancy here. It's really just researching C++ encryption libraries, continuing to implement that, or C++ encryption libraries, and making sure that encryption is a big part of my program. But that, no. And then, yeah, pretty much what I had to do is I had to fix an interoperability error with my code, and effectively what that means is there was an issue with the communication between my front end and back end code. And pretty much what happened was I just couldn't get a specific error, and it was just saying that the DLL had an error, and that wasn't really helpful. But at that point, I decided to change languages to Java and C#, so that's why I began looking at how to combine those two languages together, and then I had to rewrite all of my methods for pretty much everything that I've done up to that point. Let's talk about why I left from C++. Obviously, that file encoding error, where essentially a fancy symbol will turn into a question mark. There's exceptions where effectively they were being very vague, and I wasn't really understanding what they were really referencing because they weren't explicitly saying the line of the error. And then just adding libraries, because you have to physically compile C++ code in order to add to your application. In comparison to Java, which I ultimately decided to switch to, because I was more familiar with it, but there was still much more to learn in terms of how I could store and encrypt data. My advisors were much more familiar with it because they actually coded in Java on a day-to-day basis. And then the libraries are easy to use, especially with this plugin called Maven, which essentially allows you to take dependencies and effectively add them in really quickly instead of having to download and do all the weird stuff. In terms of winter break, I use this really to catch up on my project. So I researched my advisor's recommendation to use a library called JASP for my encryption. And this allows me to specify the algorithm as well as the specifics of how I want to encrypt my data, and that's why I really included it. I created an encryption class, which pretty much could interpret everything that I've done, tested my code, and pretty much documented any errors and made sure everything was good to top there. I implemented side features, and that is where the hash generator really comes in, and just that hash would generate. And then I sent my code to be reviewed to my advisors to make sure that it was good and as effective as it could be. Pitfalls. So pretty much this is an image. And
I would just pause right there for a second. Those of you who have to get to class, go ahead and quietly leave here if you would, and then
encrypted data and one which is just you can't really see a visual difference, and you might be wondering, well, what's going on? I think this is working because I can see the difference. Well, that's because my program is saying that it's drawing that, but it's really not actually manipulating those pixels. And those pixels are actually supposed to be red pixels. So that was really a problem that I had to fix in the month of January in order to ensure that I was staying on my timeline. And in terms of January, I began researching the combination of how I could take all of my methods that were already existing and how I could effectively combine my ciphers in order to make it so that a user can encrypt the data how they want and make it easy for the user to define how they want to encrypt. And I also wrote code to combine these ciphers, and that's partially where the hash generator came in, because I also made it so that the hashes can't be attacked by just looking over the shoulder and reading, well, how are you encrypting and decrypting your data? So essentially then it's just a bunch of mangled text instead of something which the user can read. And then we also have writing file-specific methods, because originally I was focusing on strings, and then I was thinking, well, later I could then take the existing methods that I have and implement them.
Kelly Smith, please call 66547. Kelly Smith, please call 66547.
And then in terms of encryption, I was using the JASP library, as I was talking about earlier. There's also something called the Java cryptography extension, and these are essentially encryption method providers which can be used with JASP in order to encrypt data how you want. And then it's slightly less user-friendly because the user actually has to install it, but it's much more powerful because then the user could install modern algorithms and then use them in creation. And here's where I really overcome the issue of steganography. So this is a secret message which is repeated 150 times. Let's just put it in the image there. There it is. You can't really tell the difference until I show you what my code pretty much generated as those pixels were modified, and then that's really the difference where the whites are pixels which were modified by my program, and black which are the pixels. February, I was looking into audio steganography because I figured, well, since I have images, I might as well expand my project scope to something like audio. And that's really that entire month. And once again, why stop at images? And really, we just take the idea of pixels and just apply them to frames. And essentially, what really matters is just to avoid this header. And the header essentially defines how the audio file should be played, as well as how it should sound. And effectively, the chunk size is very important because that defines each of the frame lengths. And then with that frame, I can take the least significant bit, as I said earlier, and then store some data. If you want to hear a demo of that in terms of audio, I can show that at my board. And then, once again, this is really just finishing up implementing the current methods to files, which took me quite a while because there were bugs there. And then I wanted to password protect my data, but then I figured, well, really that's just simply using the cipher to decrypt my data. And then I just looked into researching JPEG cosine curve steganography, which I was looking at earlier, which was that master project. And let's talk about that, because I know quite a bit about that. So JPEGs are essentially a lossy format, so I can't really just do LSB steganography on it because it's a compressed format, and then when I save the image, it'll use the changes that I do. But what I really want to care about is in this process of doing an image, what I really care about is those DCT coefficients. And DCT coefficients are essentially splitting the pixels of an image to an 8x8 block, running an algorithm on them, and then effectively taking those values which are returned, getting the binary representation of that, and then doing the least significant bit once again. Least significant bit's a very common concept in steganography. And there you go, there's an array. And here's a panda, which is a JPEG image. And then the advantage to JPEG cosine curve steganography is that you can see these chunky shapes in here. And in comparison with LSB steganography, it's very noisy. So really what this allows me to do is if somebody gets the original image and subtracts them, essentially what happens is they might think, well, this is just a compressed image, rather than something which is deliberately somebody trying to store data. April, I was looking at implementing a compression library because one of the things that I noticed was that on my original prototype, the encrypted text was much longer than the original text, so what I wanted to do is compress that down with the compression library and prepare for final project presentation. But really, what happened was this happened in January in terms of compression libraries, just because I managed to get a little bit ahead in the month of January. I added some research to the JPEG cosine curve steganography techniques, so I knew a little bit more about it and really implemented it. And this is pretty much where I am right now in my project. So really, I was using the JAI, Java Advanced Imaging Library, in order to get the DCT coefficients of the image. And then I managed to successfully extract all of the DCT coefficients, as you can see there, with this code, JAI. But I can't seem to figure out how to save those images because JAI has a very lacking documentation in terms of what and I guess we can do questions real quick.
Yep, go ahead. Any questions? You guys all understood what you said?
So, when you're doing the image steganography and you have the
Good morning, Sylvia.
All right, hold on, we gotta pause, sorry.